Okay, so we're going to talk about how to multiply polynomials. In our previous videos, we've talked about how to add and subtract polynomials, and then of course we talked about exponent rules. And so section 5.5 gets into how to multiply polynomials. And this is something that should be pretty simple for you if you can do the product rule. So if you remember in section 5.1, we talked about the product rule, and it said that if you are multiplying and you have the same base, you keep your base and add exponents. That is exactly what this first problem says. This problem says that we've got x cubed, multiplying it by x squared. We have the same base. And so based off the product rule, we're going to simply keep that base and we're going to add exponents. So 3 plus 2 is 5. And there's our final answer. And we talked a good bit about using that product rule throughout that first section. And you've seen that in most of these other sections that we've talked about. And so really that's all we're doing in this section is we're simply using the product rule. So if you look at the next problem, we have talked about how to distribute, right? The distributive property. In, I think, chapter 1, we talked about the distributive property. And we said that in that distributive property, you multiply this term that's outside the parentheses times everything inside the parentheses. And so when we do 5m cubed times 2m, again, it's just using the product rule. And so we know we can multiply 5 times 2 and get 10. M cubed times m is m to the fourth. Then you can do that with the next term, 5m cubed times 7. Well, 7 times 5 is 35. And then bring over the m cubed. And so there is then our final answer. If you can do that, distributive property where you are using that product rule, because again, m cubed times m is m to the fourth. Well, that's the product rule. That's what it says. Keep your base, add your exponents. If you can do that, then you can do any of these that we're going to do in this section. Literally, that is all there is to it. Okay? So, if you look at the next one, same exact thing. We're going to take 2x to the fourth times 3x squared. And we're just going to distribute. So, when we do distribute to the first term, we're going to multiply the 2 and 3 and get 6. And then x to the fourth times x squared. Again, x is our base. We'll keep it. Add your exponents, 4 plus 2, and you get 6. Do the same thing with 2x to the fourth times 2x. Again, multiply the 2's, and you get 4. And we have x to the fifth, because x to the fourth times x is x to the fifth. And then do the same thing with the last term. So negative 5 equals. So negative 5 times 2x to the fourth is going to be negative 10 x to the fourth. And you'll notice there's not any like terms. There's nothing else we can do with that. It is now simplified. Now, I'd encourage you to pause the video and then do this next one on your own. I'll give you 3 seconds. Okay, so hopefully you pause the video, you work the next one. And again, we're going to distribute the negative 4y squared to each term. And the only thing you really have to be careful with here is to make sure that you distribute the negative. So that negative 4y squared, the negative has to get distributed. So negative 4y squared times positive 3y cubed is negative 12y to the fifth. Again, keep our base of y, add our exponents. And then negative 4y squared times 2y is negative 8y to the fourth. And then negative 4y squared times negative 4y is a positive 16y cubed. And negative 4y squared times 8 is negative 32y squared. And then again, there is our final answer. Now, if you can do that, then you can multiply polynomials. Because really what we're going to do after this is we're just going to distribute, but we might do it twice, or maybe even 3 times. But all we're doing is distributing. And so again, if you can do these problems, you shouldn't have any problem whatsoever with what's coming next. So, let's look at this. Before we get into these 2 problems, let me give you this quick example. If I were to ask you to multiply that, x plus 2 times x plus 3, how would you do it? Well, a lot of you probably look at that and you go, well, I would FOIL. I'd do first, outer, inner, last. If you're not familiar with FOIL, the F stands for first, O is for outer, I is for inner, L is for last. What does that mean? Well, the first is multiplying the first 2 terms in both binomials. The O is for the outer terms in both binomials. And if you'll notice that when you do the F and the O, you just distribute this x to the x and to the 3. Then the I is to multiply the inner terms, so the 2 on the inside. And then the L is to do the last terms. Well, again, if you'll notice, all you did was take the 2 and distribute it to x and to 3. And so I don't really like to use the term FOIL because FOIL works for binomial times binomial. It does not necessarily work for binomial times trinomial like we're about to see. But when you think about it as it's really just the distributive property, well, now that can work. And so when we're multiplying, we're simply distributing. Again, we might do it once, we might do it twice. Here, with the FOIL method, you would have had to do it twice because you take x and you distribute, and then you take 2 and you distribute. And so this process of multiplying literally is just doing the distributive property several times. Okay? So if you take that idea, and we're not going to actually FOIL that one just for the sake of time, but if you actually take that idea and use it in this first problem, well, we're going to take this m in that binomial and we're going to distribute it to all 3 terms in the trinomial. So m times m squared is m cubed, and m times negative 2m is negative 2m squared, and m times 1 is m. Okay, so that's distributing the m. Then we're going to take the 3 and we're going to distribute it. And so 3 times m squared is 3m squared. 3 times negative 2m is negative 6m. And 3 times 1 is 3. Now the only other thing we have to do is combine our like terms. And so we do have a couple terms that are m squares. They can go together. And we also have a couple terms that just have an m. They can also go together. Now, when you combine all that, we have m cubed, negative 2m squared plus 3m squared is a positive m squared. Notice when you add terms, again, we talked about this in section 4, when you add terms, you only add the coefficients. Okay, you do not change the variables. It does not become m to the 4th or anything like that. Then we're going to combine the m term, so m minus 6m is negative 5m, and then plus the 3. And there is our final answer. Now, again, I'd like you to pause the video, try this next one on your own. Alright, so hopefully you did that. Hopefully you paused the video. You've tried this one on your own. One of the questions I often get is, can I put the binomial in the front? And the answer to that is yes. I don't do that just because I don't want you to be dependent upon doing that. But yeah, if it makes you feel better to put 3p squared minus 5 in front of that trinomial, then by all means do that. I'm not going to. I'm just going to take the trinomial and distribute it to the binomial. So I'm going to take 6p squared and multiply it by both of those terms. So 6p squared times 3p squared is 18p to the fourth. And then 6p squared times negative 5 is negative 30p squared. Then I'm going to take the 2p and I'm going to distribute it to both terms. So 2p times 3p squared is 6p cubed, and 2p times negative 5 is negative 10p. And then we're going to take the last term, the negative 4, and distribute it. So negative 4 times 3p squared is negative 12p squared. And negative 4 times negative 5 is positive 20. Now, again, we need to combine like terms. So we only have the 18p to the fourth. It's the only p to the fourth term we have. And then we only have the 1p cubed term. There's 6p cubed. And we do have a couple terms that are p squared, so we can combine those. Negative 30 of those minus 12 of those is negative 42p squared. And then we have the negative 10p. And then we have the positive 20.